Hello, and welcome to my report on the Week 9 readings. Due to the upcoming test, the reading this week was shorter. The topics we covered were magnetic forces and flux. Both of these were new to me, although the concept of magnetic forces was a pretty logical progression from what we've been doing with magnetic fields. The first thing which we looked at with respect to magnetic forces was how to calculate the force on a point charge. This was denoted F(b) on Q. To calculate this force, you first take the cross product of the velocity of the point charge and the magnetic field and multiply it by the charge of the point charge. The magnitude can be found by multiplying the magnitudes Q, V and B as well as the sine of the angle separating them. We then looked at the uniform circular motion due to a magnetic force, meaning the particle moves in a circle with a constant speed. This occurs when the magnetic field is constant and perpendicular to the velocity and the magnetic force is the only force acting on the particle. Using Newton's second law, we are able to relate the radius to the strength of the magnetic field and the mass, speed and charge of the particle. This relationship looks like radius equaling m times magnitude of v over the magnitude of q times the magnitude of b. The last topic under magnetic forces was the effects of a magnetic force on a short current carrying wire. This looked like the vector delta F being equal to the conventional current times the cross product of delta L and B. After this we looked at flux. The main takeaway here was that there are two types of flux, electric and magnetic. Flux only operates orthogonally to the area we are considering, and for both types the equation is the field vector dot product with the unit normal vector times delta A. The last point we covered was that if flux occurs on a non-uniform area, you can divide the surface into many small sections and integrate over them to find the summation. For me, the hardest concept this week was definitely understanding what flux was. I feel that after reading the physics book page, I have a much better understanding. Also, the most interesting thing about these current topics with respect to my major, computer science, is how these magnetic and electric fields are taken into consideration when designing computer parts. As I said before, there was less content this week, but thank you very much for listening.